Hello everyone, and welcome back to part 2 this time of the quadratic applications, and this of course is section 3.1. But what we're going to see about this one is we're basically going to be exploiting the shape of a parabola in order to try to do some kinds of optimization. We'll see stuff about maximizing, in this case maximizing profits. We'll have stuff about maximizing areas as well. What's the largest area? We'll see that one coming up in part 3. But this one, without any further ado, why don't we just jump into this problem right here. We have somebody who owns a hot dog stand. He found that his profit is represented by this function over here, where basically P, so in other words the Y values, are the profit, and then the X values for this one that we're plugging in here is the number of hot dogs that he sells. And so in chapters previously, we modeled these kinds of things like profit and cost and revenue in a linear fashion, but this guy, he's figured out that his profits are not linear, they are quadratic. And so what we want to do is find out the number of hot dogs. So in other words, find out which X value corresponds to the maximum profit, so the highest Y value. And we would notice here that if we just graph, I'm not going to graph exactly, but if we just graph the general shape of this graph, it's going to be actually an upside down parabola because we have this negative in front of the x squared, so it's been reflected across the x-axis, and it's going to be shaped something like this. It's going to have, and here I will just be more rigorous by labeling my axes, it's going to have a vertex, and this vertex is where the maximum y value is going to happen. So if you can think back to the previous video, we found out that this vertex, it's always along the axis of symmetry. And this axis of symmetry, which of course is going to end up being the x coordinate of the vertex, is given by x equals negative b over 2a, whenever our function is given in standard form, which ours is. This one, we have the standard form, so it's already convenient to find these coefficients, the b and the a. So let's just calculate this x value, this x coordinate for the vertex. It's going to go like negative b over 2a. And the b value, of course, is the one, let me go ahead and write down again, just so that you can remember what the standard form should be. It goes ax squared plus bx plus c. And so the coefficient for the x term, that's the b, which is 22. So we have on the top negative of 22. And then on the bottom it's 2 times the a value, which the a should be the coefficient for x squared, and in our case that's just this negative 1 that is there. And so negative 22 over negative 2, basically, this will just become 11. And so he needs to sell 11 hot dogs to maximize his profits. And then we need to find out what his maximum profit actually is. And so all we need to do is find out what is the profit whenever he sells 11 hot dogs. So we will just find out what is P of 11. It'll be negative times of 11 squared, and then plus 22 times of 11, and then plus 75. And so we're just going to need to calculate this one. It will go, of course, negative 11 squared is negative 121, and then 22 times 11 is 242, and then plus 75. And then this one, we can keep simplifying a little bit, and it basically becomes 121 plus 75, which is 196. That will be his profit, and it should be dollars, of course. Now there's another question here, which is to find out what is the number of hot dogs that he needs to sell in order to break even. Now consider that breaking even just means that his profit's going to be 0. So his profit for some amount of hot dogs is 0. And since we already have an expression for the p of x over here, we can just plug it in. It just goes negative x squared plus 22x plus 75, and then this equals 0. And this is just a quadratic equation that we could solve using a number of different techniques. The quadratic formula comes to mind just because it's already in standard form. And so we could just plug in these coefficients into the quadratic formula. But you know, the quadratic formula requires you to square the b term. I don't want to do 22 squared, and then it's going to use this 75. It seems messy, so why don't we try to factor this one instead? I would start though by multiplying both sides by -1, just so that we don't have this negative sign in front of the x squared. I don't like to have it. It doesn't look nice to me. And so this -1, it would distribute throughout this one to all of these terms. And so it will go x squared minus 22x minus 75 equals, and then of course 0 times -1 is still just 0. And then this one is factorable. Think about 75. It's not the product of too many things. In particular, it's the product of 25 and 3, and those are actually the numbers we want that will add up to 22. In particular, we have that -25 and +3. These numbers will add up to 22. And so we would get that the profit is 0 whenever x is -3, or else whenever the x value is 25. So this one, if we think about this graph, which actually what I drew up here at the beginning, it's not drawn to scale, but we can imagine that this is actually the appropriate graph, where this one here is the value -3, and then this other x-intercept over here is the value of 25. And it kind of doesn't make sense, to be honest, for this problem to ask when he's going to break even, because this guy, he's able to actually make a profit whenever he sells 0 hot dogs. If you find the y-intercept over here, if we plug in x is 0, we'll find the y-intercept, and the y-intercept is actually going to be 75. So whoever this is, he's making $75 whenever he just sells 0 hot dogs, which I think that there is something wrong with this model, because there's no reason why somebody should make a profit before they even start selling any hot dogs. I think that here we would be looking for a different model that doesn't have a positive y-intercept. And so we can conclude an answer from this one, but it really doesn't make sense, because think about what this other x-intercept is. That means that he makes a profit of $0 whenever he sells 25 hot dogs, and then after that the graph is below the x-axis, and so he actually continues to lose money after he sells more than 25 hot dogs. And it seems very strange to me. But anyways, we could guess that, you know, -3 hot dogs is not possible, so we can say 25. He's going to break even at 25, but then if he sells more, he doesn't make money, so that doesn't really make sense. But anyways, we will continue with this area problem, this number 3, in the next video. I think it's a really good one to look at. But anyways, thank you guys for watching.